So let us consider semiconductors chapter now. Consider the junction diode as ideal. This meaning is the ideal diode has forward resistance 0. Voltage drop across it will be 0. So by using this condition, if you solve this, it's very simple. Apply the Kirchhoff's voltage law. VA voltage across the A is 4, okay, and VB is minus 6. It is in forward bias. Then we can say, applying Kirchhoff's law here, current I equals to potential difference between them is 4 minus of minus 6 divided by resistance is 1 kilo ohms. Then we can say 10 by 1000 amperes, or it is 10 to the power minus 2 amperes. Very simple. Here the keyword that you have to understand is ideal diode. Ideal stands for forward resistance is 0. If you don't know this, you have to know that, okay. The next second problem is the given circuit has two ideal diodes connected as shown in the figure, okay. They are also ideal diodes, they said, has two ideal diodes. If they are in forward bias, remember, if an ideal diode is there, if it is in forward bias, then it will connect, so resistance will be 0. Reverse bias, then it will be open circuit, okay. Forward bias la closed circuit, reverse bias la open circuit. Then this diode is in reverse bias, that you can see it's a positive and negative here. So it will open circuit, the current will not go through the D1, and diode D2 will be open, so closed circuit, it will pass through the D2, okay. Then we can say the 10 volt supply should be across the, the voltage drop across the 2 ohm, that is 2I, and the voltage drop across this is again 2I. Sum of these two drops should be equals to 10 volts. Then current I equals to 10 by 4 will give you 2.5 amperes. I hope you got it. Right? So 2.5 amperes, and most of the students will consider will not have the idea that which one is forward bias, which one is reverse bias, okay. If you don't know how to figure out the forward bias and reverse bias conditions, you can't solve this problem. And some people will have the idea that which is forward and which is reverse, but they don't know what is the meaning of the ideal diode stands for, okay. If you don't know ideal diode behavior also, it will be problem for you to solve this, okay. So you should know both, how to decide whether forward bias or reverse bias, and what is the meaning of ideal diode. I told you already, ideal diode stands for in forward bias it will be open circuit, it will be closed circuit, and it offers 0 resistance. And reverse bias, it is open circuit, it offers infinitely many resistance, or we can say reverse bias, okay. Resistance is going to be in the order of 10 to the power of 6 ohms, okay. So this you have to remember. Next, the given graph, it is application of photodiode, that is solar cell, which is clearly given in the NCERT textbook, okay. And if you read the NCERT textbook, it will be easy to answer this. This A is called as open circuit voltage. A is VOC, right. B is ISC, short circuit current, okay. These two they have clearly given in the book also, okay. And this problem is asked in 2014 directly from NCERT, okay, and option A is correct answer, okay. And to solve this, no need to solve anything, because no problem, no calculations, nothing. If you read this, if you remember this, you can answer directly option 1. If you don't know, if you forget this formula, diagram, you can't answer this, okay. So just remember the NCERT, don't forget to read the NCERT, okay. And next, so this is application of Zener diode, okay. In this they are asking, let us see the question first of all, let us see the keywords that you have to decode. The Zener diode having breakdown voltage equals to 15 volts. This 15 volts is VZ, okay. Zener breakdown voltage is 15 volts. And in voltage regulator circuit in the figure, the current through the diode will be how much? That means through the Zener diode the current is how much? That is Iz. If you remember my class, the total current equals to Zener current plus load current, and from here we can rewrite the Zener current equals to total current minus load current. Okay, and here I given a formula. The total current is supply voltage minus Zener voltage by series resistance. Load current is Zener voltage by load resistance. Zener voltage by load resistance. So series resistance is this 250 ohms. Load resistance is this one 1 kilo ohms. Okay, substituting here, trust me, you will get 5 milliamperes is the answer. Okay, this is the Zener current, right? So this is based on the Zener diode application. It is okay. You have to read the applications and regulation process also I have explained. You should read my notes, class notes, so that you can understand. Next, a PN photodiode. It is photodiode. Remember, whenever you see the photodiode, you have to get the idea that photoelectric effect. The principle of working photoelectric effect, right? The photoelectric effect is converting of light energy into electrical energy, and this phenomena happens in case of photodiode. And now the band gap they have given mentioned here. The band gap is the work function. Remember, band gap is the work function, that is pi. Then we can say the work function equals to, according to Einstein, which is hc by lambda naught. Lambda naught is the threshold wavelength. They are asking the threshold wavelength only. Okay, so lambda naught equals to hc by work function. Hc value, it is 12,400 divided by work function is 2.5. If it is in electron volt, then you can say this everything will be in angstroms. Then solving this lambda naught, you will get the answer 12,400 by 5 by 2. Okay, so multiply and divide with 2, you will get 4. The 2 5s are 10. So 1240 is approximately 48,000, or it is 49,000 angstroms something. Okay, less than 5,000 angstroms. But what is the property of the threshold? What is the meaning of the threshold wavelength? The maximum wavelength that it can be detected. Okay, so maximum wavelength is 5,000 angstroms. Then 4,000 nanometers is the first option, which is greater than 5,000 angstroms. Okay, and 6,000 nanometers also greater than 5,000 angstroms. 6,000 angstroms also greater than 5,000 angstroms. 4,000 angstroms is less than 5,000 angstroms. Okay, so the threshold wavelength is nothing but the maximum wavelength. Okay, to be detected by the photocell or photodiode, it should be the wavelength, incident wavelength should be less than the threshold wavelength. Okay, so 4,000 is less than the 5,000, so this is going to be correct answer. Next, if a full wave rectifier circuit is operating from 50 hertz mains, this input frequency is 50 hertz, and they are asking ripple will be how much. What is ripple here? The ripple is nothing but the output of the full wave rectifier is this. Okay, the frequency terms in the output is called as ripple. Okay, the ripple has frequency. The frequency of ripple is 2 times the frequency of input. Remember this. So input frequency is 50, then output frequency will be 100 hertz. I hope you got it. And next it is the combination of following gates. The output Y can be written in terms of inputs A and B. They are asking output. Okay, so if you can remember my class, it is XOR gate. Okay, XOR gate, which is given in the class itself, but you want me to show the proof here. Okay, so A is given here, so it will come A here. Okay, and B has been complemented, so B bar. So it's an AND gate it is, so A B bar. Similarly here it is B A bar, and this is OR gate, then A B bar plus B A bar. will be the output. That is option C. Okay. So, this diagram we discussed, and here itself I can give you the XNOR gate also. XNOR gate is this way. XNOR gate is this. Okay, output of the XNOR gate is AB plus A bar B bar. This is the output of exclusive NOR gate. Okay. Next, they have given 4 diagrams, and out of the 4 they are asking us to pick out the AND gate, NAND gate, NOT gate. Okay, this is AND gate, NAND gate, NOR gate. So 2, 4, 3 is the correct answer, option D. So just it is very simple and straightforward, right? And last, I think it is for the logic circuit shown, the truth table is what? First of all, to decide the truth table, either you should substitute A, B values like A and B 0, 0, 0, 1, 1, 0, 1, 1. Output is Y here. You should take that A 0, B 1, B 0, A it is 1. Okay, everything you have to cross check. Instead of cross checking, you can substitute A here and A bar over here because it's a NOT gate, and B is B bar. Then it is not, it is a NOR gate. So A bar plus B bar whole bar, right? A bar plus B bar whole bar will be A bar bar into B bar bar. Bar cancels, then you will get AB, right? So A into B. A into B is AND gate. Okay, so AND gate truth table is option 1. Okay, if it is both are high, then only it is high, output is high. That is, so it's very simple and straightforward.